Hello, future engineers, subscribers, viewers, and students. Here is a video in statics. This video is about solutions to problems given as quiz problems in my different classes in statics from the university where I teach statics. I hope that through this video, all viewers, subscribers will be able to enhance their skills in statics. So, hello viewers, subscribers, and students. Here is the solution to the third problem in the quiz which I gave in one of my classes in statics. Here is the problem. Determine the moment of the force shown about point B, negative 236, and point C, which is at 5, 1, negative 3. So F2 has a magnitude of 640 newtons. That's the given, although it's not mentioned here or labeled here, but it's 640 newtons. So let's transform or express F2 in vector form, boldface. So it is directed to the left, up, and forward. So the x component is negative. So F2 is 640 times quantity negative cosine 30 to solve this uh, xz component. Then we multiply that further by sine 40 I. So F2 is 640 quantity negative cosine 30 sine of 40 I plus sine 30 degrees J, the vertical component, and 640 times cosine 30, which is this, then times cosine 40 for the z component k. Simplifying, it is equal to negative 356.27 I plus 320.0 J plus 424.58 K quantity newtons. Now let's locate F2 at A and let's locate point B as shown in this figure here. So this is point A, which is positive 4, positive 3, then positive 2. That's point A. Point B is negative 2, positive 3, then forward 6. So the box reduces to a rectangle. Point B is to the left of A. The distance is going to the left 4 plus going to the left 2, so 6. And since A is 3 meters above the XZ plane, B is also 3 meters above the XZ plane. There's no dimension along Y, so it is 0. That's why the box reduces to this rectangle. And the Z distance, because A is 2 meters in front of XY plane, B is 6 meters in front of XY plane, so the distance between A and B along the Z-axis is 4 meters as shown. So the dimension of the rectangle joining points A and B is, the dimensions are rather 4 meters along Z and 6 meters along X. So by scalar approach, moment about Bx is by right thumb rule positive 320 times 4 only. This 424.58 passes through the Bx axis, so it has no moment. So it is 320 times 4. And it is equal to 1280 Newton meter. Summation of moment about By, that's the positive sense, so it is 356.27 times 4, then minus 424.58 times 6. So 356.27 times 4 minus 424.58 times 6. And that is equal to negative 1122 Newton meter. Lastly, summation of moment about BC, this is the positive sense. So it is only 320 times 6. 356.27 passes through the BZ axis because this lies on the same plane as this rectangle. So moment about BZ is 320 times 6, and that is equal to 1920 Newton meter. So let's check these answers by the vector approach. It should be RBA cross the force. Moment about B is RBA cross F2. By the way, if it is a vector, it should be boldface or with an arrowhead on top. So BA, so from B going to A, we move to the right 6, up or down 0, then backward 4. So it is 6, 0, negative 4 for RBA. 6, 0, negative 4, components of the force, and unit vectors ijk. Copy the elements of the first two columns, 6, 0, negative 356.27, 320, then ij. So for I, check with your calculator, it is 0 times 424.58, 0, then minus 320 times negative 4, so that's plus 1 to 80. For the y component, negative 4 times negative 56.27, so that's positive. Then minus 424.58 times 6, which is that. So it is negative 1122. It checks there. Then for k, 6 times 320, which is that, and minus 356.27 times 0, so it is 6 times 320, which is 1920. Therefore, MB is in vector form. That's the final answer. 1 to 80, quantity 1 to 80i minus 1122j plus 1920k Newton meter. So that's the answer for moment of this force F2 about point P. Now let's locate C. It is 5, so to the right of A, 1 below A, and negative 3 at the back of A. So that's it. So this is point C. And the dimensions of the box would be, if we draw a box, the delta x is 1, 5 minus 4 is 1. A is above C by 2 units, 2 meters. Then A is in front of C by 3 plus 2, 3 plus 2, so it is 5. So let's draw a box. So C is to the right of A, below A, and at the back of A. So this is the box. The dimension is 1. 1 is equal to 5 minus 4. Then 2 meters is y of A, which is 3, minus y of C, which is 1, and that is 2 meters. Then along Z, it is 5 because A is in front of the XY plane, uh, 2 meters, while C is at the back of the XY plane, 3 meters. So 2 plus 3 is 5, which is this. So MCX by right-hand rule or by scalar approach is equal to 424.58 times 2 meters and minus 320 times 5. MCX is 424.58 times 2 minus 320 times 5, negative 750.8 Newton meter. Then MCY is, this is the y-axis, so positive 424.58 times 1, then minus 356.27 times 5. And that is equal to negative 1357 Newton meter. Then finally, moment about CZ here, that's the positive sense. So positive 356.27 times 2, then minus 320 times 1. Positive 356.27 times 2 minus 320 times 1. And that is 392.5 Newton meter. So let's check by the vector approach. It is MC is RCA cross F. So from C to A, we move to the left. So what? negative 1, upward 2, negative 1, 2, then forward 5. So RCA is negative 1, 2, 5. Then components of the force, then unit vectors ijk. Copy the elements of the first two columns, negative 1, 2, negative 3, 5, 6.27, 320, ij. So for I, 424.58 times 2, which is this, then minus 320 times 5, which is that. So negative 750.8. For j, negative 356.27 times 5, which is this negative here, then minus 424.58 times negative 1, so that's plus 424.58 times 1, which checks here, negative 1357 Newton meter. And finally, for K, 320 times 1, negative 1, which is this, negative 320 times 1, then minus negative 356.27 times 2, so that's plus 356.27 times 2, so 392.5. So M sub C in vector form is negative quantity negative 750.8 I minus 1357J plus 392.5 K Newton meter. So that's it for this problem.